Hello students, today we will learn how to divide. Surprised? We all know about division algorithm in numbers called as Euclidean Division algorithm. In arithmetic, Euclidean division or division with remainder is the process of dividing one integer by another in a way that it produces a quotient and a remainder smaller than the divisor. When we divide number, say 31, with 3, we get quotient as 10 and remainder as 1. In this case, 31 is the dividend, 3 is the divisor, 10 is the quotient and 1 is the remainder. This division can be expressed as dividend is equal to divisor into quotient plus remainder. This expression is called as Euclid's division lemma. In other words, dividend is obtained by multiplying the divisor with the quotient and adding the remainder. This whole process of carrying out step-by-step division is called as integer division algorithm, the best known as long division method. The division algorithm states that when an integer a is divided by another non-zero integer b, then there exist unique integers q and r as their quotient and remainder, such that a is equal to bq plus r as the result of Euclidean division. Note students, r is always 0 or less than b, that is divisor. This implies that we have to carry out long division till the remainder becomes less than divisor or 0. Now, the question is this algorithm applicable to the division of polynomial or not? Let's find out. A polynomial can be divided by another polynomial of lower degree than itself using long division method. So let's recall how to divide polynomial by another polynomial. For example, divide minus x square plus 5x cube plus 6 by x minus 4. The first thing is to write polynomial in their standard form with all its missing terms if they are not there. We already know how to write a polynomial in its standard form. Accordingly, we get 5x cube minus x square plus 0x plus 6. This polynomial is also called as the dividend p of x, and here divisor is x minus 4. The quotient and remainder can then be determined as follows. Divide the first term of the dividend by the first term of the divisor. That is, we divide 5x cube with the x and get 5x square, which is the first term of the quotient. Place the term above the bar where we write quotient. Multiply the divisor with the term just obtained. Now write the result under the first two terms of the dividend. After this, subtract the terms just obtained from the appropriate terms of the original polynomial and write the result underneath. After carrying out subtraction, we get remainder 19x square. Now bring down the next term from the dividend to become 19x square plus 0x. In the next step, consider this remainder 19x square plus 0x as new dividend while the divisor remains the same, and repeat all division steps. To get the next term of the divisor, we divide first term 19x square of the new dividend with the first term of the divisor. This is the second term of the quotient. Now multiply the divisor with the term just obtained. That is, we multiply 19x with x minus 4 to get the product 19x square minus 76x. Write the result under the first two terms of the dividend and subtract the terms just obtained from the appropriate terms of the new dividend and write the result underneath. After carrying out subtraction, we get remainder 76x. Then bring down the next term of the dividend to become 76x plus 6. Again, repeat the steps to get the third term of the divisor. Likewise, we get the third term as 76 and the new remainder as 310. Students, this process continues till the degree of new dividend is less than the divisor. At this stage, this new dividend becomes the final remainder now. Here, in our case, we get remainder as 310, whose degree is 0, which is less than the degree of divisor, which is 1. The polynomial above the bar is the quotient q of x, which is equal to 5x square plus 19x plus 76. And the number left over, that is 310, is the remainder r of x. This division can easily be verified. First, multiply x minus 4 by 5x square plus 19x plus 76, which is 5x cube minus x square minus 304. Therefore, x minus 4 into 5x cube plus 19x plus 76. On solving, we get 5x cube minus x square minus 304 plus 310. On further solving, we get 5x cube minus x square plus 6. To generalize, just like Euclid's division algorithm, we can write relation for divisor, dividend, remainder and quotient, that is, dividend is equal to quotient into divisor plus remainder. That is, if p of x and g of x are any two polynomials with g of x not equal to 0, then we can find polynomials q of x and r of x such that p of x is equal to q of x into g of x plus r of x, where r of x is equal to 0 or degree of r of x is less than degree of g of x. This result is called division algorithm for polynomials. We know, students, that r can either 0 or some other polynomial of degree lower than the degree of divisor g of x. The result r is equal to 0 occurs if and only if the polynomial p of x has g of x as its factor. Thus, long division is one of means for testing whether one polynomial has another polynomial as its factor or not. Also, g of x will be 0 of that polynomial. Let's take another example. Divide 3x cube plus 16x square plus 21x plus 20 by x plus 4. As we can observe, the polynomial 3 of x cube plus 16x square plus 21x plus 20 has higher degree, and so we take it as dividend p of x, and x plus 4 with lower degree as divisor q of x. For first term of quotient q of x, divide first term of p of x by first term of g of x. We get 3x cube upon x, which is equal to 3x square, right above the bar. Also, multiply 3x square with x plus 4 and write products below p of x as shown. Now, subtract 3x cube plus 12x square from p of x by changing signs appropriately. We get remainder as 4x square plus 21x plus 20. Now, observe degree of r is still larger than divisor x plus 4. So division process continues till we get r with lesser degree. Solving further, we get second term of q of x as 4x and new remainder as 5x plus 20. Again, repeat the step and observe that remainder is 0. Hence, the division stops. So we get quotient as q of x is equal to 3x square plus 4x plus 5 and remainder r of x is equal to 0. Since remainder is 0, x plus 4 is the 0 of polynomial 3x cube plus 16x square plus 21x plus 20. We can verify this by replacing x by minus 4 in the expression and find its value. We observe that it comes out to be 0.